Okay, so we're going to work out this problem. We have a firecracker exploding from the center of a coconut of mass M. And so if we take a look, here's our coconut right here. It's going to explode, break off into 3 pieces. And what you'll notice is we're trying to find the velocity for piece B and piece A. So to work this one out, we're going to use conservation of momentum. We know that no external forces act, so the total momentum of the system has to remain the same. The momentum before would be 0, so the momentum after is going to have to be 0 as well. Now, what we're going to do here is we're going to start by looking at the direction separately. Just like we do with velocity and forces and all that, we have to break it into components. Okay, and they're suggesting we orient the coordinate plane. We're not going to do that. We're going to orient it like this. Take a minute to figure out what the angles are. This one right here is going to be 40, and this one right here will also be 40. Okay, so let's start by doing an equation for the momentum acting in, let's say, the x direction, so horizontal. Okay, and we're going to look at how that momentum is conserved. So that's what that means is the momentum before has to be equal to the momentum after. So we'll say momentum for A plus momentum for B plus momentum for C before and after have to be the same. Okay, now before and after, these are all equal to 0 because before it's at rest. Okay, after, since object B is acting entirely in the vertical direction, then after that's equal to 0. So that tells us that PA, and this is all in the x direction, by the way, that means that PA is going to be equal to negative PC. Okay? Well, now we've got to bring in these equations, or bring in these angles. So momentum is mv, so this will be m times VA, and this will be cosine of 40, since we want that x component. Okay, so that will be equal to m of c times v of c times cos 40. Okay, so to continue, it says that PC has a mass of 0.3 m, piece B has a mass of 0.2 m. Okay, so if the total object has a mass of 1 m, what would be the mass of A? Well, it's going to have to be 0.5. So we're going to say 0.5 m times velocity of A times cos 40 equals 0.3 m times velocity of C times cos 40. Okay, well, since these two are the same, since cos 40 and cos 40 are the same, they drop out. The m's are going to drop out. Okay, and so they say that 0.5 VA equals, and this should be negative right here, negative 0.3 VC. All right, if VC is 5, okay, go ahead and solve for VA. So that's going to give us velocity of particle A of negative 3 meters per second. Okay, so that's the speed of one of the particles. And now we're going to find the speed for the other one. And the way we're going to do that is by using the conservation of momentum for the y direction. And it's going to start the same. We're going to say the initial momentum equals the final momentum. And this initial momentum is 0 because at first none of them had any momentum. So 0 equals PA, and these are all for the y direction now, plus PB plus PC. Okay, so that means that 0 equals, for PA, it's going to be upward, so it's positive, so that will be, so we get, for the mass, it was 0.5 m, it has a velocity of negative, and we'll just use positive here since it's going up, a velocity of 3, and it's at an angle of 40, so we're going to use sine of 40 for A. Okay, for B, we're going to have a downward momentum, and so it's going to be negative, and we're going to say for B it was 0.2 m, and it had, we don't know the velocity, we want to find that. And then finally for C, it's upward, so it's positive. It had a mass of 0.3 m. It had a velocity of 5 meters per second, and it was also at an angle upward. Okay, so we can go ahead and solve this. M is going to drop out of the equation. So right there, right there, right there. And let's go ahead and find what the velocity of object B is. Okay, so we punched all that in, we do some simplifying, and we find that the velocity of object B is going to be 9.6 meters per second, and this is downward. Okay, and there we go.